Mathematics. Muslim contributions to mathematics in the Golden Age can only be described as monumental. Mathematics itself is, of course, the basis for almost all other sciences, including physics, chemistry, astronomy, and geography. For Muslim scientists of the Golden Age, however, it was also a sacred science. They hoped that through the understanding of advanced mathematics, they could discover the underlying numerical principles that dictate the natural rules of the world. Today, anyone who has taken a basic physics class understands that formulas dictate the movement of objects through space. In the Golden Ages, that formula was a mystery, and through theory and experimentation, scientists hoped to find these seemingly magical algorithms. Through that understanding, a greater appreciation and love for God's power and relationship with His creation could be achieved, making mathematical study a religious journey as well. One of the first great Muslim mathematicians was Muhammad ibn Musa al-Khwarizmi, a Persian who lived from 780 to 850. He was one of the first to work at the House of Wisdom, and thus laid the groundwork for future advances in mathematics. Among his greatest contributions was the adoption of the Indian numerical system and its dissemination. Previously, the de facto system was based on the ubiquitous Roman numerals, which had their limitations. Complex math problems involving non-integer numbers were near impossible with the Roman system, but the Indian system, 1, 2, 3, 4, and so on, allowed large and negative numbers to be more easily expressed, easing complex problems. Al-Khwarizmi not only borrowed the system from the ancient Indians, but also added onto it an important missing link, the zero. Although he was unable to mathematically prove zero, since anything divided by zero is undefined, Al-Khwarizmi implemented it in his further studies, revolutionizing some subjects and inventing others. Perhaps Al-Khwarizmi's greatest contribution was the development of algebra. In his monumental work, the compendious book on calculation by completion and balancing, he explains how algebraic equations can be used to solve everyday problems, ranging from dividing up inheritance to geography. Here, Al-Khwarizmi was a trailblazer. While the ancient Greeks were masters of geometry, they failed to separate theoretical algebra from it, and thus found limitations to the science. Al-Khwarizmi's book established algebra as a unique subject within mathematics with its own practical applications. In fact, the word algebra itself derives from Al-Khwarizmi's title for his book. It comes from al-jabr, meaning completion, referring to the balancing of both sides of an algebraic equation to find a solution. Another great Persian mathematician was Omar Khayyam, who lived from 1048 to 1131. Although he is mostly known in the West for his poetry on love and mysticism, he was also an accomplished mathematician, helping to push the boundaries of the subject in ways his predecessors could not. He managed to find a method for solving cubic equations, algebraic expressions in which the variable is raised to a power of 3. Pushing further into theoretical algebra, he was also one of the earliest, if not the first, to formulate the binomial theorem, which helps solve algebraic expressions by expanding them into sums. These discoveries may seem overly theoretical and only useful for torturing secondary school math students, but they have important applications. Through advanced algebra, subjects such as trigonometry and calculus could be developed. Muslims further developed trigonometry itself, particularly the 10th century scientist al-Battani, for a very practical reason. Through trigonometric functions and a basic understanding of the stars, people could calculate their exact position on Earth, which was of vital importance for Muslims who must pray in the direction of Mecca. Handbooks produced in the Golden Age listed hundreds of cities, their coordinates, and the direction from there to Mecca. For this reason, many mosques built over 1,000 years ago are now being found to point directly at Mecca, even from thousands of kilometers away. The basic trigonometric properties put forth by Muslim mathematicians even serve as the basis for how GPS systems work today.